Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill. In this skill, we are going to be talking about how to troubleshoot a Kubernetes cluster. Now, Kubernetes itself is a pretty complex tool. You've got all of these different nodes running inside of your cluster. You've got your master nodes, you've got your worker nodes, and then you've also got your machines that you're using to interact with applications. So you could be an administrator using a desktop or laptop computer in order to interact with the API server that runs on your master nodes to manage resources, to deploy applications, to make configuration changes to existing applications. And then you've also got your application end users out here. And you got to remember that at the end of the day, our objective by running a Kubernetes cluster is ultimately to serve these application end users who are hitting different services, typically through a web browser, but they could be using other types of services as well. And they're going to be hitting these services from outside the cluster. So we need to ensure that the cluster itself is healthy, to ensure our master nodes are running, to make sure that our API server is available, to make sure that the worker nodes and the kubelet component that is running on each of those worker nodes is able to communicate with the master nodes via the API server so that they can receive their instructions. So, making sure that that cluster is healthy and functional is foundational in order to ensure that the applications that are actually running on the cluster itself are accessible by these application end users up here. So as an administrator of a Kubernetes cluster, or maybe even multiple Kubernetes clusters, you are going to need to know how to troubleshoot what is going on inside of a cluster. So let's talk about some of the things that could potentially go wrong within a Kubernetes cluster. For starter, we've got one of the issues that you might see is the inability to download images. So if you're hosting container images or running pods that are based on container images that are stored in an external registry somewhere. It could be the Docker Hub, it could be Quay.io, it could be Amazon Elastic Container Registry, it could be Azure Container Registry, or really any external registry out there that's not running internal to the cluster. It's very possible that your cluster nodes, the worker nodes that are actually responsible for running pods on your Kubernetes cluster, may not be able to download container images from a remote registry. That could happen for a variety of different reasons. And typically you're going to be looking at the network layer, kind of layer 3 type of things, to figure out why those nodes are not able to communicate with the Docker Hub. So one potential problem, one potential root cause could be a lack of routes. So there is no route to get out to the internet so that they can locate the Docker Hub endpoints. Another potential issue, even preceding routing to the external internet, is potentially the inability to resolve DNS names. So if your worker nodes for some reason do not have the ability to resolve DNS names like docker.io or quay.io or whatever DNS addresses Elastic Container Registry is using, typically that has your account ID in it as well for AWS, but if it's not able to resolve those DNS addresses, then it doesn't even know what target IP address it wants to contact in order to get out to this container image registry. So that's one issue that you might come across, especially if you are commonly working with networking configurations, cloud-based networking configurations in services like Amazon Virtual Private Cloud or Microsoft Azure Virtual Networks, or if maybe you're running your own Kubernetes cluster on premises as well, and you're responsible for any routing devices, physical devices in your network that need to be configured, it's very possible that either DNS or routing issues could potentially cause a lack of connectivity to an external registry that is important, imperative to running your business applications on your cluster. So that's one potential issue. Another potential issue that you could have at the network layer is the inability for your worker nodes down here to communicate with your master nodes. And that could happen, again, from a kind of layer 3 perspective where maybe the worker nodes don't have a valid route to get over to the network where the master nodes reside. It's entirely possible for you to have your master nodes and your worker nodes on completely different networks, and it's incumbent upon you as a network administrator, perhaps, to configure the routes to ensure that you do have IP connectivity between all of those devices, as well as typically the master nodes are going to have a load balancer sitting in front of them so that the worker nodes, when they're making requests out to the API server that's running on these master nodes, you'll need to be able to ensure that those nodes can route through that load balancer over to the API server on the Kubernetes master nodes. Now, from more of a software perspective, you can also run into issues with the software that's either running on the master nodes, like the API server, for example, or the worker nodes as well. So from a software perspective, you got to remember that the master nodes have the API server component running on them, and the worker nodes have a little component down here. I just used the Kubernetes logo to kind of indicate what that is down here running on each of these nodes, but it's called the kubelet. And the kubelet is basically the worker process that's running on each of your worker nodes, and that kubelet is responsible for communicating with these master nodes right up here to receive different instructions from those nodes. So if you deploy a pod, a service, well, not really a service so much. It could be like a node port service, for example, but any pods and containers that you're deploying out to your environment, those pods are ultimately going to be executed by these worker nodes down here, unless they're kind of a system level component that would run up on the master nodes. For example, etcd, the key value store that's backing Kubernetes, that runs on master nodes. You've also got your core DNS as well that runs on your master nodes. So the master nodes do run some pods and containers on them, but generally speaking, for your application end users out here, when you're deploying business applications, those are going to get sent out to the worker nodes so that your end users can access those through typically a load balancer. So you have high availability across multiple pods within the cluster. So you want to make sure that this kubelet component is healthy on each of these nodes, that it's in the running state. It depends on which runtime you're using on your Linux-based hosts. If you're using Ubuntu Linux, for example, you'd have systemd as a service controller, and that service controller needs to ensure that the kubelet component is always up and running. If that kubelet were to die for any reason, then that node would effectively be out of service because it's not communicating with your Kubernetes cluster. So those are a couple of software issues that you can run into. I've also seen a number of issues around the container networking interfaces, or CNIs, for your Kubernetes cluster as well. When you're setting up a new cluster, so in my separate skill here at CBT Nuggets, where I talk about setting up a cluster from scratch on your own virtual machines using the kubeadm utility, that's kind of the official tool to install Kubernetes clusters from scratch on your own virtual machines. But what can happen is if you spin up a new cluster and you have not yet installed a CNI into your cluster, like Flannel or Calico or WeaveNet or any CNI that you can use to set up your cluster network, then the core DNS pods that are running on your Kubernetes master nodes will actually not come online. Those core DNS pods just won't come online until the valid CNI has been installed into the system. I've also seen another issue where running Kubernetes in an Amazon Elastic Kubernetes cluster, or EKS, Elastic Kubernetes Service, if you're using that cloud-hosted version of it, one thing that I had actually done recently is installed the Calico CNI into my cluster here, which is a third-party open source CNI, and so that effectively broke the AWS VPC CNI that's native to an EKS cluster in your AWS account. And so after I uninstalled Calico, that's actually, I believe, what the action was that actually broke the AWS VPC CNI. And so what was happening is these worker nodes down here were showing in this not ready state. And so if you run a kubectl get nodes and you see this message saying not ready on your nodes, it's very possible that you could be running into some kind of issue with the kubelet or with the container network interface that's preventing network connectivity to your pods. And so therefore the pods won't get scheduled, and ultimately your application containers won't get spun up. So in order to troubleshoot a Kubernetes cluster, there's a couple of different places that you can go. I mean, of course, you can use systemd, systemctl to interact with the systemd service controller and ensure that your core components like the kubelet are up and running on your worker nodes. And there's also some log files that you can take a look at. In cloud-based solutions for Kubernetes like Linode's manager or AWS's EKS service or Azure Kubernetes service, AKS. A lot of those managed services create an opaque layer that you can't see through in order to get to your master nodes. So those are all just managed for you. You don't have access to those master nodes. However, in cases where you're setting up your own cluster on your own virtual machines using a Kubernetes distribution like Kind, Kubernetes in Docker, or K3s, for example, which is just a standalone binary, very easy to deploy. And then you've also got things like kubeadm, of course, that you can use to set up your own cluster. So in those cases, you'll actually have access to the master nodes themselves. You can SSH into each of those master nodes individually or use some kind of configuration management tool and automate those types of tasks and actually retrieve log file information about those systems. And so there's actually a really good document over here on the Kubernetes documentation under tasks and then monitoring, logging, and debugging. And it's just called Troubleshoot Clusters. And this contains some commands that you can run in order to get high-level information about your cluster and figure out where any potential configuration problems may exist so that you can go and then resolve those. So one of those things that I wanted to mention here is this logging section. And if you do have access to your master nodes, you can actually head under the var log directory and you'll be able to find your API server logs. So the API server is what kubectl will communicate with in order to create and manage resources on your cluster. You've also got the kube scheduler log as well, and the scheduler component is essentially what determines which worker node in a cluster should receive a particular workload. So if maybe you have a constraint or on one of your pods that says I have to have a system that has at least 8 cores on its CPU, then the kube scheduler is responsible for identifying which nodes in the cluster satisfy those constraints, and it will basically tell those worker nodes which pods they should be running on. And then you've also got the kube controller manager here. So this is essentially what takes your API resources and figures out how to basically make your desired state become the actual state. So that's where that declarative management comes into play on Kubernetes clusters. So the controller manager looks at the resources that you send into the API server, and then it figures out how to kind of get those services and resources up and running on the cluster. Now on the worker node side, we have the kubelet log, and this is probably, I would argue, the most important log on your worker nodes, especially when you're talking about managed services where you don't even have access to your master nodes at all. It's just completely managed for you. But if you're just debugging your worker nodes, you'll want to look at the kubelet log to see if there are any problems with the kubelet running on that system. And if you're not seeing any log entries in the kubelet log, then that's probably a good indication that the kubelet service itself isn't even running on those virtual machines. And so you want to make sure that you reconfigure that kubelet to be up and running on those VMs. And then you've also got this kube proxy component here as well that runs on each of the worker nodes. And that, as the documentation says, is responsible for load balancing on your services within your cluster. So they give you a few other examples of situations that could be, or root causes that could cause problems inside of your Kubernetes cluster. So for example, if you shut down any virtual machines that are part of your cluster, they could be master nodes, they could be worker nodes. If any of those VMs get shut down, then it's quite possible that you may not have enough capacity in your cluster to run all of the pods that you have asked the cluster to run for you. So that could create a potential problem. As we talked about a little bit earlier, there could be network partitioning or routing issues, layer 3 level routing issues that could cause connectivity issues between worker nodes or even between master nodes themselves. Maybe the master nodes just don't have routes to each other. Or maybe there's a firewall that's blocking, even if there is a valid route in place, there could be a firewall that's actually blocking, port 6443, for example, that's preventing communication to the API server. Also, crashes or just bugs in the Kubernetes software components, things like the kubelet running on the worker nodes or the API server component. There is always the possibility that you could actually encounter a bug in the Kubernetes software, especially if you're running outdated versions of it. You'll want to make sure that you generally keep your cluster up to date. And so that could potentially be a root cause as well. And that's where you want to look at the log files for each of the components to figure out if one of those components is actually crashing and then just continuously restarting itself using the service manager. There's also the ability to lose your persistent storage. So if you're running in a cloud environment where you have persistent storage on Elastic Block Storage in AWS, for example, then it's possible that application components could crash because they're simply missing data that was maybe deleted by another administrator who didn't understand what a particular block storage volume was being used for, or something like that. So you want to keep just in mind that any dependencies on data state that application components may have in a Kubernetes cluster, you want to make sure that those are healthy. And then finally is operator error here. So it's always possible that an operator could come along who has access to a cluster, and maybe they're not familiar intimately with how Kubernetes clusters work. And so they could see this kubelet process running on one of their Linux servers, and they say, oh, this is taking up a bunch of resources. Why do I need this running on my virtual machine? And so they just choose to uninstall or delete or use their system service manager like systemd to disable that service entirely. And so that could cause connectivity issues between that node and the cluster if that component is shut down, and that could potentially break the applications running on your cluster. So there's a lot of different things that could potentially go wrong. We also talked about things like CNI issues potentially that could be causing issues within your Kubernetes cluster. And so we're going to take a look at a couple examples in the rest of this skill. I hope this has been informative for you, and I'd like to thank you for viewing.